All right, we've got like 8 examples of increasing awesomeness. We're going to start off slow. For part A, cosine inverse of the cosine of pi over 4, I'm going to show you 2 ways of doing it. And you'll realize why I'll have to show you 2. So first off, let me just copy it down real quick. According to the rules here, notice that pi over 4 is in the range of cosine inverse, 0 to pi. So what happens to the cosine and the cosine inverse? They what? They cancel. We don't want them to explode. Yes, so again, cosine inverse is on the outside, the inverse is on the outside. We worry about the range now. The range is 0 to pi. Since the angle in question is between 0 and pi, these 2 cancel. And we just get pi over 4. Now that process is going to work some of the time. The other times, what has to happen is we have to work inside out. So working inside out, the inside is the cosine of pi over 4. What is the cosine of pi over 4, class? Radical 2 over 2. So just modifying the inside, I've replaced the cosine of pi over 4 with radical 2 over 2. Is that step okay? Okay. So now notice this problem becomes like our first 3 problems in this section. So we would ask ourselves, what angle between 0 and pi has a cosine value of radical 2 over 2? Pi over 4. So irregardless of which method we use, we're going to get the same answer. Oh, I didn't mean to move you. I led you on there. I'm so sorry. Move this over. There we go. But the first method in green there may not always work. We might have to work inside out. Cough, cough. Part C, cough. Is it part C? It's part C. Questions. Oh, you know what? It's part B. Why, hello. Sine inverse of the sine of 5 pi over 6. Tell me a little something about sine inverse. What's its range? Yeah. Inclusive? Well, is 5 pi over 6 between negative pi over 2 and pi over 2? No, not usually. Not in this country. So because of that, does the sine inverse of sine cancel each other out for this problem? No. Now in the previous one where we had the cosine of cosine inverse of 5, since 5 wasn't even the domain, it was undefined, we couldn't even do it. However, we can still take the sine of 5 pi over 6, that's legal. What is the sine of 5 pi over 6? Oh, forgot my file. Yeah, the sine of 5 pi over 6 is 1/2. So now you're going to ask yourself, the sine of what angle between negative pi over 2 and pi over 2 is 1/2? Pi over 6. Very good, that, students. So let's talk about what just happened. So here is the angle 5 pi over 6. Here is the angle pi over 6. What do they have in common? Yeah, one angle is the pi over 6 is the reference angle of 5 pi over 6. But what value do they have in common? One more time? No. What coordinate do they have in common? How about we say it that way? The y coordinate. They both have a y coordinate of 1/2. So even though the original question was about 5 pi over 6, since sine only returns in quadrants 1 and 4, and since this was a positive 1/2, that meant that we had to be in quadrant 1 somewhere. So we go right across pi over 6 positive. So we did not get back what we started with, but that's okay. We can deal with that. All right. Oh my gosh. Look at that. You got chocolate in my peanut butter in part C. Sine of cosine inverse of radical, I think that's supposed to be a 3 over 2. Well, see these 6 rules? They don't even matter anymore because they're not even the same function. We can't even use them at all. Wah, wah. All right, for these guys, you have to work inside out. So let's start with the inside. Cosine inverse of radical 3 over 2. So you ask yourself, the cosine of what angle between 0 and pi gives me a cosine value of radical 3 over 2? Huh? 30 degrees. The cosine of what angle between 0 and pi or 0 and 180 degrees has a cosine value of radical 3 over 2? 30 degrees. So now we're back in chapter 6. What's the sine of 30 degrees? 1/2. Mike? Yeah? Thanks for forcing us to memorize the unit circle, because otherwise this would be impossible. I know, student. You're welcome. So let's work inside out. What's the sine of negative pi over 4? Try it again. Negative radical 2 over 2. Because negative pi over 4 is in quadrant 4, and sine is negative there. So pi, that's 0, negative pi over 4. Is that okay? Okay. So cosine inverse of negative radical 2 over 2. So what angle between 0 and pi has a cosine inverse of negative radical 2 over 2? 3 pi over 4. Very good, or 135 degrees. So again, your all students say calculus comes back and says, hello, because since cosine returns in quadrants 1 and 2, and the number in question is negative, that means we must be in quadrant 2. So notice in each of these ranges here, one of the quadrants is positive for that function, and the other one is negative for that function. Well, guess what, kids? All of the quadrant 1s must be the positive one, and the other guys must be the negative one, because everything is positive in quadrant 1.